So let's now have a look at how we use the three trigonometric ratios I've just got back in front of me now to find an unknown angle rather than an unknown side. Now, to be able to do this, you'll need a right angled triangle that you know two of the sides of. You might know all three of the sides, and that's great, but you at least need two of the sides to be able to use this formula correctly. So in terms of what we're going to be doing in the step-by-step, it's going to be the same as finding the unknown sides, except our unknown will end up being, rather than an unknown side, it will be an unknown angle instead. So let's take a look at a couple of examples. So this one here, really you've only got the one situation that you're working through where, you know, the unknown sides are mentioned that there's kind of two situations algebraically that you can get yourself in. The key thing is probably getting the correct ratio and substituting into your ratio correctly. That's probably the trickiest step that I see people, you know, we need to make sure that we're getting right, because otherwise if we choose the wrong ratio, we're not going to get the correct answer. So our first step, we need to label the triangle correctly. So we always start with the hypotenuse, which is the longest side. And then we look where our reference angle that we're after is, which in this case is the theta, so it's just here. And our opposite of that reference angle is the 3 centimeters here, so that's what we're going to label as our opposite. And then our adjacent becomes our third side, and adjacent just means next to the angle as well. So as previously, I would suggest at this point that you record what information you have. So our reference angle, we don't know what that is. However, we do know our opposite, which is 3 centimeters, and we do know our adjacent, which is 4 centimeters. So what we're going to look for is a trigonometric ratio from our SOHCAHTOA stuff, which has both the opposite and the adjacent. So we look at the sine, that has opposite and hypotenuse, so that doesn't have both. Cos, that has adjacent but doesn't have the opposite, it's adjacent and hypotenuse. So the tangent has both the opposite and the adjacent, so clearly it's the tangent ratio that we need. And remember, TOA isn't the tangent ratio. We need to record the formula for the tangent ratio, which is tan theta equals opposite over adjacent. At this point, we now need to substitute our information that we have. So we don't have the angle this time. We've got the tan of the angle, which is equal to the opposite, which is 3, divided by the adjacent, which is 4. And now we need to solve, rather than for the tan of the angle, we need the angle. So we kind of need to split apart this tangent and the theta, which in our algebraic rules, we always think about doing the inverse of the opposite to be able to solve this. Now, there is something that's called the inverse of tan. So to solve this, what we actually need to do is we need to take the inverse of tan, which we write like tan to the power of -1, of whatever's on this right-hand side, and we put that in brackets. So we're going to take the inverse of tan of whatever's on the other side, and that's how we actually solve for our angle rather than the tan of our angle. Now, this on your calculator is generally like this key is generally above the normal tangent key, and to get to it, you'll need to press like the shift or the second function, like you would, with other things that are just above it. So we just plug this into our calculator now. We end up with tan of 3 divided by 4. So we end up with an angle that's approximately 37 degrees. I'm not going to go into any decimal places with this one. So the key with this is probably getting the correct ratio right, like I said. So let's have a look at another one, which is going to require a different ratio. So over here, we have our hypotenuse this time is the 6 meters. We actually do know our hypotenuse, and that's opposite our right angle. Our reference angle's at the top left here. So opposite our reference angle is the 2 meters. So we label that as opposite, and then the adjacent becomes the third side. Let's record now the information that we have. So our reference angle is what we're looking for. We do have the opposite, which is 2 meters. And we also have the hypotenuse, which is 6 meters. So looking at our 3 ratios now, we can see here that the sine ratio does have both the opposite and hypotenuse. The other two don't. So we're looking for the sine ratio. So let's make sure we actually write the sine ratio down. So sine theta equals opposite over hypotenuse. And now we substitute into our formula. So our ratio here. So our opposite here is 2. Hypotenuse is 6. And like we did before, we need the opposite of sine. So if the opposite of tan is the inverse of tan, the opposite of sine is the inverse of sine. So sine to the power of -1, which we refer to as the inverse of sine of 2 on 6. I could have actually written that as 1 over 3 because it is just 1/3. But we just plug this into our calculator now. What was that? Yep. And we end up with an angle that is approximately 19 degrees to the nearest degree. So, like I said, the key thing with these is just making sure that you get the correct ratio in hand. Obviously, I've shown you an example with the tangent ratio, an example with the sine ratio. If you do get the cos ratio and you're up to this step, it's the same as what we did with all the others. We do the cos inverse of whatever we have. But make sure you get the, once you make sure you get the ratio correct, you substitute in it and you do the inverse of the ratio that you have in order to find the angle.